This is a problem of inverse variation. The speed at which it takes you to travel somewhere varies inversely with the time it takes to get there. Okay, this is an inverse variation problem. Now there's lots of different types of variation, right? Let's put down a few of them. First of all, there's direct variation, correct? Direct variation means that if you have a variable y, it is proportional to x, meaning if you increase x, then y increases by a proportional amount, and that proportion is k. That's the constant of proportion, right? You could also have direct with the square, in which case if y varies directly with the square of x, you'd set up this equation. What we're dealing with here is an inverse problem. As one item goes up, the other goes down, and the proportion, or the equation is y is equal to k divided by x. And it makes sense. If y increases in value, x has to decrease in value to keep that equation the same. Okay, so having said all that, let me just erase what I have here, if I can. Alright, and I'll erase that piece right there too. Okay, since we're dealing with an inverse problem, now let's assign some reasonable variables. We have speed and time, right? Let's let speed equal v for velocity, and let's let time equal t for time. Since we're dealing with inverse variation, the velocity is equal to some constant divided by time. That's different than what you're used to dealing with in regular proportion. By the way, if you cross multiply, right, you'll see that an equivalent equation to this is that v times t is equal to k times 1, or vt is equal to k. And that's the formula that I prefer to use for inverse variation. Okay, so anyway, we have that basic formula. Now here we're given some information. Let's say it takes you 12 minutes to get somewhere driving 54 miles an hour. Okay, velocity is 54, time is 12, and that's equal to some constant k. Alright, well, a constant is a constant, meaning if we multiply those two values together, and let me get my calculator up here. If you multiply the 54 times the 12, you get 648. So that's my constant. And that's the constant for the entire length of this problem. Anytime you multiply the velocity times the time, you're going to get 648, right? And let's just mentally test this to see if it makes sense. Let's say you go twice as fast, right? Twice as fast of 54 is 108. Doesn't it make sense that if you go twice as fast, you're going to get there in half the time? And you can check this. If you multiply 6 times 108, you're going to get 648. So the constant, the constant of this inverse variation is 648. Okay, so we know that k is equal to 648. So the question we have now is, how fast do you drive to get there in 10 minutes? Well, how fast is v? Time is 10. So v times 10 is equal to, right, 648. And a simple division by 10 shows you that the velocity has to be 64.8. Meaning that if you want to get there in 10 minutes, you got to ramp up the speed to 64.8, or about 11 miles an hour faster. Alright, so this is inverse variation, and it's real simple. You just have to start with the basic formula. Velocity is equal to k divided by t, or whatever your two inverse variation variables are. Set them up with this formula, cross multiply to get a different similar form, figure out what that constant is, and then figure out the problem that you're asked to solve. Hope this helps.